Hello, I just dropped a new article on my Substack about something called the hand problem. It's absolutely fascinating. The Wall Street Journal just did an article about it, but it's been a problem in robotics for a while. And it has to do with this paradox. And it's the fact that there are things in robotics that are easy for robots to do, like work in hostile environments or work for 24 hours at a time or do certain tasks with great precision, like put together a microchip. But there are things that we can do very easily, like pick up a grape, something a toddler can do, that's very hard for a robot to do. And it's because of the way that our hands move. We have so many degrees of motion in our hands that robots do not have yet. So they're trying to work out this hand problem. Like, should robot hands have 5 fingers? Should they have 3? Should they have 6? And some robot hands, they have grippers, right? Should they be 3 fingers and push up against a wall, right? How much force should they have? Right? They're working out all of these problems. And this is one of the things that's still keeping robots from being in our homes. If you saw the Time magazine article about figure AI, it was loading laundry in and out for this reporter, but dropped some of the laundry, right? And that's because of the hand problem. That's something that's easy for us to do, although I do occasionally drop laundry myself, but hard for robots to do because of the gripping. So I have a slideshow that's going to come right after I'm done waving my hands at you here, and it's going to explain the hand problem, and I go into more detail about it with a lot of different videos and things on my Substack, which is droids.substack.com. Check it out. I have some very handy references over there. So check that out. It's droids.substack.com.
All right. Before we jump in, I want you to do something for me. Just for a second, take a look at your own hand. Go ahead. Flex your fingers, make a fist, maybe pick up something nearby. It's kind of mind-blowing when you really think about it, right? As one robotics researcher said, our hands are so much more amazing than we give them credit for. And for the folks in robotics, trying to replicate this incredible tool is one of the toughest nuts they have ever tried to crack.
In that quote, it nails it. This is what's known in the engineering world as the hands problem. And honestly, it's the biggest bottleneck holding back the whole humanoid robot dream. If you can solve this, you can finally have robots that can work right alongside us, using our tools in our world. The stakes, they really couldn't be higher.
So, what is it that makes this challenge so unbelievably difficult? Well, to really get it, you've got to appreciate the machine they're all trying to copy in the first place. Yeah, for ages, engineers have looked at the human hand as, well, the gold standard, the perfect blueprint for a robot. And when you break down the specs, you totally see why.
First up, just the hardware itself. Your hand? It's built on this framework of 27 different bones, all working together. It's a structure that's both super strong and incredibly flexible. And what powers that bony structure? More than 30 different muscles. Now, some of them are right there in your palm, but a bunch are actually in your forearm, pulling on these long tendons, almost like a puppeteer pulling strings.
So, you take all those bones, all those muscles, and what you get is something engineers call degrees of freedom. The human hand has around 24 of them. That just means there are 24 unique ways it can bend and twist and pivot, giving it this insane range of motion. But see, it's not just one of these things, it's the whole package. You've got the biomechanics, the physical parts. Then you've got perception, this super dense network of sensors that are constantly telling your brain about pressure and texture and heat. And finally, you've got the control system, the brain, right? This unbelievably sophisticated computer piloting the whole operation. Trying to copy just one of those is a nightmare. Trying to replicate all 3 in a small, lightweight hand, that is the ultimate robotics challenge.
So faced with this impossible task, how do you even start? Well, it turns out the engineering world is kind of split. There are 2 totally different philosophies on how to solve the hands problem.
And this table here, it shows you that split perfectly. Look at the human hand, 30+ muscles, 24 degrees of freedom. It's just off the charts complex. Now check out Tesla's Optimus. Same 5 fingers, sure, But they've slashed that complexity down to 11 degrees of freedom with only 6 actuators. And then you've got Boston Dynamics' Atlas. They took it even further. Just 3 fingers, only 7 degrees of freedom. I mean, that is a huge difference.
And that difference in the data really points to these two competing ideas. On one side, you've got what we can call the mimicry approach. That's Tesla's Optimus. They're trying to replicate the human form with 5 fingers and a tendon system, hoping that a human-like design will lead to human-like versatility. But on the other side, you've got the pragmatic approach. That's Boston Dynamics. They basically looked at it and asked, do we really need a perfect human copy for warehouse work? And their answer was no. So they ditched the idea of mimicry for a simpler, tougher, 3-fingered hand that's just focused on one thing, grabbing stuff reliably.
You know that pragmatic choice from Boston Dynamics? It's a clue to a much bigger shift that's happening across the entire field of robotics. People are starting to question that original assumption, the one that says the human hand is the only design worth copying.
And that leads us right to this really provocative question that a major research paper asked point blank. Do robots even need human-like hands at all? So a huge review of a bunch of robotic studies came back with some frankly shocking results that kind of flip everything we thought we knew on its head. Turns out, 3 fingers is often the sweet spot. It's that perfect balance of being dexterous but also simple. And get this, having a really flexible wrist can actually be more important for grabbing things than how many fingers you have. Some non-human designs, maybe with 4 or even 6 fingers, can actually do certain tasks better than a 5-fingered hand. And, this is my favorite part, even simple 2-fingered grippers can pull off some pretty complex moves just by cleverly using a table or a wall like a virtual 3rd finger. Okay, but here it is, the real bombshell from all that research. After looking at dozens and dozens of different robotic hands, they found absolutely 0 correlation between how complex a hand was, how many fingers or motors it had, and how well it actually performed on difficult tasks. Let me say that again. More complex does not mean more capable. That is a massive, massive finding. It basically turns decades of robotics assumptions upside down. So, where do we go from here? Well, it all points to a much smarter future for robotics. One where we're focused on right-sizing the tool for the job, instead of just chasing this one perfect biological blueprint.
And that means we have to redefine the goal itself. The real target isn't perfect mimicry, it's dexterity. And dexterity just means having the right tool for the task at hand. Sometimes, that might be a 5-fingered hand. But a lot of other times, a simple suction cup might get the job done way more efficiently and reliably. This totally changes the game plan. It gives us a new, much more practical way to solve the hands problem. Step 1. Analyze the task. What does the robot actually need to do? Step 2. Choose the right tool. The simplest gripper might just outperform a super complex hand. And Step 3. Move the complexity. Take it out of the fragile, expensive hardware and put it into smart software, better control systems, and smarter sensors.
All right, so this is all super interesting if you're an engineer, but why should the rest of us care about the hands problem?
The short answer? 2 words. $5 trillion. That's what some analysts think the humanoid robot market could be worth by 2050. Solving manipulation, cracking the hands problem, that's the key that unlocks this absolutely gigantic economic shift. It's going to change everything from how we make things to how we care for the elderly. And that brings us to one last idea to leave you with. For decades, robotics has been inspired by our own bodies, but maybe it's also been limited by them. This new research is showing that non-human designs can actually be better. So it makes you wonder, if we stop trying to just build copies of ourselves, what kind of incredible new abilities could robots unlock, things we can't even imagine yet?